Hello doctors. Today let's talk about neuro-ophthalmology. If you see in this image, this is the eyes and this is the occipital lobe. The pathway runs like this and we are going to dissect this pathway and learn about it. Now here if you see there are two people standing. The photo is taken from the top angle. Now let's take this head and let's shave off the hair. The head becomes like this. Now if you see here, this is the eyes and this is the nose. Here is the occipital lobe and here is where our visual cortex is present. So the pathway runs like this. This is the pathway roughly. Now let's dissect this and learn about it. If you see from the screen, now as you are sitting, if you are just seeing your screen, this is your right side and this is the left side. This is the right and this is left. Now this is the right eye, left eye and nose and ear. Now let's take the right eye and divide it into two halves. Let's assume that there is one half near to the nose and the other half near to the ear. Now in the right eye, the half that is near to the ear sees the outside world, which is in the medial side. Now in the eye that is near to the nose sees the outside world, that is on the lateral side. Now you can see here, this is just one eye, right eye. If you see the left eye, it's just the same. The left eye, let's divide it into two, and the part which is near to the nose, or let's first take the part that is near to the ear, sees the outside world, that is in the medial side. The part near the nose sees the outside world, that is in the lateral side. This is how we see the outside world. Now we all know that behind the eyes there is optic nerve. As we just divided the right eye into two halves, let's just divide the optic nerve into two halves. Just this yellow color optic nerve supplies the yellow part of the eye. This violet color supplies the violet part. Just like that for the left eye. Now we can see here the medial part of the optic nerve, that is near to the nose. The two optic nerves cross each other. This part is called as optic chiasm. Now this part lies just near to the pituitary gland. After this part, the paths intersect and cross each other. If you can see, this yellow part is now coming to the left side and this green part is still on the left side. This forms the optic tract. Same follows for the right side. Now you can see how in the starting we divided the right eye into two and the left eye into two. But as we go through in the brain, we can see these paths intersect and how we look changes. This form is called as lateral geniculate body. This lateral geniculate body, if you can see in the left side, it has inputs from the eye, the left eye and also the right eye. So the left side lateral geniculate body has inputs from both the eyes. Just like that, the right side lateral geniculate body has inputs from both the eyes. Yes, from the lateral geniculate body, the information then passes through the visual cortex, that is in the posterior or occipital lobe. Now just for your clear understanding, now you can see here there are four objects in front of you. If you see this smiley and this heart, let's see how it moves through in your eyes. These four objects are in front of you, but in your eyes it becomes like this. The smiley comes here and the heart goes here. That is, Your eye that was near to the nose, that was seeing the lateral half of the world. Your eye that was near to the ears, that was seeing the medial half of the world. Just like that, you can see for the left eye, this box and this circle, they just cross over. Now after this, let's trace out the path. If you see, the smiley that was here has just come here, but the box that was here, the box that was here, is still on the same side. So this is the lateral geniculate body. This has inputs from both the eyes. This smiley came from the right eye and this box from the left eye. Just like that, this circle came from the left eye and this heart came from the right eye. Now these informations pass on to the visual cortex and the image is processed.